Hello again. We are going to prove some parts of parallelograms are congruent. And I've drawn a parallelogram, and what I'm going to do is I'm going to draw one of the diagonals. And based off of this, A, B, C, D, I want to prove that the two triangles are congruent. And there are a lot of different ways that we can do this. One way is angle side angle. And in order to do that, what we would need is to recognize the fact that since ABCD is a parallelogram, AB is parallel, segment AB is parallel to DC, and AD is parallel to BC. And the reason why, and I'll put statement over here, is that this is the definition sorry about the spelling again, of a parallelogram. Definition says opposite sides are parallel. Now, if you have two parallel lines and AD or AC is a diagonal, we actually have two angles. This angle right here and that angle right there are alternate interior angles. So we can say that angle BAC is congruent to angle DCA because of alternate interior angles are congruent. Because anytime you say something, you want to give a reason why, and the reasons are always definitions. So the reasons are going to be definitions, postulates, theorems, axioms, anything you've proven. And that's the only thing we could do. You can't say, well, because it looks like it. That's just not how we do that. Now, also, since these two, AD and BC, are parallel, these two angles are congruent. So we can say angle DAC is congruent to angle BAC for the same reason, which is why I kind of lumped them all together with the same reason. Now, I have two angles, and since I'm proving triangles are that triangle ABC is going to be congruent to triangle AD or ACD, I can only use side, 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 angle, side, angle, or angle, angle, side. Now, in this case, since we're going after the parallel lines and finding two angles, we don't want to use side, 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 or side, angle, side. We could use angle, side, angle, or angle, angle, side. If we want to go the angle, side, angle route, what we'll do is we need the angle between the two congruent angles, which is your diagonal. So what we'll say is segment AC is congruent to segment AC, and the reason why is the reflexive property, which is really A equals A. Anything is equal to itself. And then from here, we now have angle, side, angle, angle, side, angle. We can say that triangle ACB is congruent to triangle CAD by angle, side, angle. If we go the angle, angle, side route, then what we can say is we just need to pick one of the opposite sides. We can say that AB is congruent to CD by the definition of a parallelogram. And so we would have AB and BC, in this case I have to put 2, sorry about that. And you get angle, angle, side, angle, angle, side. And from there we can say that triangle ACB is congruent to triangle CAD by angle, angle, side. And then we'll put a QED afterwards because we've proven that these parallelograms are congruent to each other. Now, if you don't want to use angles, I'm going to have to draw a couple things for you. Let's draw another parallelogram. Let's go ahead and draw the transversal. Same thing, A, B, C, D. And now what we can say is segment AB is congruent to segment DC, and segment AD is congruent to segment BC by the definition of a parallelogram. Next, we can say that AC is congruent to itself, AC, by the reflexive property. And that's enough to give us, for triangle ACB is congruent to triangle CAD by side, side, side. And then we can say QED. As a matter of fact, we could have found side, angle, side. You could have had those two sides. I forgot to put that in there. There's your side, 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 side. You could have also just had those two sides and know that opposite angles are congruent to each other. That would have worked as well. You could have done side, angle, side if you wanted to. Now, the key for this is, since this works for parallelograms, it's going to work for rectangles, for rhombuses, as well as for squares. Because a square is a parallelogram, a rectangle is a parallelogram, a rhombus is a parallelogram. You just have to remember that a rectangle has special features. Diagonals are congruent, and interior angles are equal to 90 degrees. For rhombuses, diagonals are perpendicular, and all four sides are congruent. And for squares, all four sides are congruent. All four angles are 90 degrees, so we have perpendicular sides. All diagonals are congruent and perpendicular. So there are different characteristics, extra characteristics that we could use to prove different situations for parallelograms. But being able to prove that these triangles work are going to help us, especially if we wanted to, and I won't put this up until we've done it in class. If you have a parallelogram that looks like this, and you throw both diagonals up here, And as an extension, try to figure this one out on your own, just using all your properties. There are 4 triangles here. Which triangles are congruent? And why are they? That's the thing. You just can't say that they're congruent. You have to explain why they are. And you have to be specific. Remember, it's the closing arguments of a huge trial. You have to prove beyond a reasonable doubt. Prove beyond a reasonable doubt that the triangles are congruent. Good luck.